Hi guys, welcome back to the channel. If you're new here, my name is Lee and I'm a DIY electric skateboard builder. In this series, I'm going to be showing you how to make a DIY electric mountain board. From scratch, component parts. All the way to a fully ripping, shredding dirt machine. Let's do this. Hello guys, my name is Lee and welcome back to my channel. In this series, we are building a Trampa electric mountain board. This is episode 3 where we're going to be looking at the speed controllers. These are two VESCs from Enclosure. They are the Foxbox. They're really well known. They're probably, up until recently, the best speed controller you could buy. I have ordered a Unity for this board because these can only really run in FOC mode. They can switch about 50 amps. 50 amps per motor is good, but I'm building a board with a large battery for long range. It would also be nice to have lots of power on tap if we need it, so lots of current. These top out, like I say, at 50 amps. The Unity that's coming out can handle a lot more amps. So eventually we will be putting a Unity in here and rescuing these because these are cool to have for like single motor boards, which I may or may not build in the future. So, but for now they're going to go in here. What I do know that I'm going to do at the moment is these wires are going to be secured to the drives using these holes. So the wires are going to come down and they're going to come back into an enclosure. So this will be both sides here. I think looking at the speed controllers, I wonder whether the best way to mount these, put that in the middle, like that. I've also got to get some other bits in here. Let me go and fetch them. I have the Antispark and its switch. So there's that's got to go in here. So obviously we'll be taking the power in down these wires, and then in here somewhere these wires will be splitting off to each speed controller. So that's got to go in with its switch. The receiver for the remote control has got to go in here, and also Bluetooth module has also got to go in here. So all of these things have got to go in this box. So try and make it as small as possible, but bearing in mind I have to fit all these things. We'll see how it turns out. Let's take some measurements of the speed controllers and jump onto the computer. So I sat down on the computer and designed a VESC enclosure, and this is what I came up with. This is printed in nylon, super durable, and I also have a lid for it. As you can see, I put Trampa's logo and my name on the bottom, and this is going to house the electronics. I did make some guides for the speed controllers themselves, so they'll sit in there nicely with the phase wires going into these ports and the power wires coming out of here. So without further ado, let's get on the bench and get started. Right, first thing first, these are going to mount in, which way around we're going to do it? So these are going to mount in here and in so the wires are going to go like that. Right, before we go any further, I just want to have a mock-up on the board. These wires need to be quite short from the Foxbox so that I don't have excess wire. Okay, cool. Or at least we've got some sort of gauge now about where to snip the wires. So I got some bullet connectors from Luke at Streetwing. Top man, thank you very much, bro. And basically I'm going to cut these wires quite short and attach the sockets onto these wires. Then I can fit the speed controllers into the enclosures. So Man, I really need to get a knife. Can't believe I haven't got a knife. Now we just need to fill some half buckets. Now this is where it's going to be tricky. We've got to heat up the bucket and get the wire in. Right, all 3 bullets are soldered on. Let's test it in the case. Right, these will be heat shrinked, but we don't know at the moment which way round the motor wires are going to go, so for now they'll just be kept bare. Okay, so both motor controllers are installed, and I've shortened all the wires. This new solder I'm using just flows so much. Had a few little mishaps, but nothing that's going to affect the performance of the connection, and once it's all heat shrunk up you won't see it anyway. So the issue I have is I don't actually have a place drilled yet for the switch. I'm hoping I can put it there. I don't know though, because the power input wires coming through here, so I'm not sure. Maybe it goes there, we'll find out. Let's see what else we've got. We've got receiver. I have to decide which one's going to be master and slave, and because this wire, which is where the receiver goes, is closest to this tray, I'm going to use this one as the master. Plug that into channel 1 for now. That's going to go somewhere down there. In fact, I think that's probably the best place for it, in that corner, out the way. And then the Bluetooth. Into the slave. Now this can be hidden. I'm hoping to get it up there. There we go. That's going to make the case bulge, that's a bad idea. It can be lost. It can be lost up there anyway. Bluetooth, receiver, Antispark. Now this is a tough one. What I need to do is break out from XT90 to 2 XT60s. So I need to have a, those cables are pretty big, those wires. Plus the Antispark switch is going to go, it really feels like that's going to go there. Could even go there. Not sure. Actually, having thought about it, there's actually no point in having this XT90. I could just have 2 XT60 wires coming from each terminal and going to these 2 VESCs, and the power wires soldered directly on. If I need to disconnect them, I've got 2 connections there. So I'm going to desolder this XT90. We don't need it. So I have some AWG12, and I'm going to make up the flying leads for the speed controller. Speed controllers. So okay, I have the Antispark switch wired up now to the 2 controllers. There is a heatsink that's got to go on there, but I'll do that later on. First of all, I'm going to solder the incoming power wires direct to the Antispark switch. So as you can see guys, I've got the speed controllers installed in the case along with the Antispark and the switch, the on-off switch. And I've also got a Bluetooth dongle in here so that we can get the telemetry data from the speed controllers. They are connected by CAN, as you can see here. I have a CAN cable going round, so they'll be able to communicate with each other, and the Bluetooth module will be able to see data from both controllers. And I also have this Y-split cable, if you like. Pretty proud of this one. Managed to get it all in this little box. It's very neat, very tidy. If you want to print your own one of these boxes, guys, there is a link in the description. Follow that and download the STL files and you'll be able to print yourself one of these boxes for your Trampa. Right guys, the only problem we have is the heatsink for the Antispark fell off while I was making this, and I've tried to scrape back as much of the glue as I can, as I dare do, basically, without damaging the chips. I've cleaned the chips off. And we're going to need to reinstall this plate back onto the Antispark now with some more glue and some thermal paste, so stand by. Right then guys, I'm going to be using my favourite thermal paste, which is Thermal Grizzly by Cryonaut. This stuff is really good. My favourite paste. I'm going to use it on all my computers and I'm going to use it on this. And you really don't need making a mess. That is far too much, but we'll continue. I'm not too worried about putting too much glue on this, guys, because I'm going to wrap it up anyway. So, right, okay, guys, that's gone off. So, just gonna. I would normally use self-amalgamating tape here, but I haven't actually got any. So, for now, it'll have to be electrical tape. Right, guys, the last thing that I want to do is I was going to use this HM10 Bluetooth receiver, but actually, Trampa just released a VESC dongle from Benjamin Vedder, which enables you to use the latest VESC tool to configure these speed controllers, and also Trampa are bringing out some remotes that will connect to this. So I am not going to use the HM10 anymore. I'm going to use the dongle, but I don't know if you can see, the connector is wider than the HM10 and this won't actually fit in the FOC box, so we've got to put that connector onto this dongle. We've got a pin out here of what wire does what, and we've got a pin out here of what wire does what on there, and all we need to know is we'll just copy the HM10. Quite nice, it's already wrapped in there as well. Hopefully you can read that, but I can see the pinouts there. We've got all the various bits and pieces, so I can switch this cable over to the dongle now. So first of all, the yellow wire is receive, and the yellow wire is receive on the dongle. Need some jeweler's screwdrivers. I've got some somewhere. So all I'm actually doing here, guys, is I'm just taking the connectors out, then I'm just swapping them over one by one so I can't get this wrong. Cool. Done. So I've swapped over the connector from the HM10 onto the Trampa dongle, so that should now go in okay. So which one's the receiver going into? That one. So this one needs to go in here. There we go. I'm also going to wrap that in electrical tape too. I'm sure it's got conformal coating on it, but a bit of extra won't hurt. Cool, so everything's done, everything's in there neatly. Obviously these, I used some new solder on these ones and it was so flowy, it was ridiculous. So it's gone down the connectors, but that doesn't matter. These will be heat shrunk when it goes on the board. Everything fits in nice, I'm very happy with that. And obviously the phase wires will come in here and attach to these. So let's get the board and let's get this on the board. The general plan is that this is going to sit there like so, and these wires will come over the bindings into the battery box. Just work out the height. I don't want it up here, and I can't have it right down at the floor because of the wires, so maybe like there. I don't know, we need some dual lock. This stuff is dual lock, and if you're not familiar with this, it is the best Velcro you can get. They actually do a high strength version of this, but this is plenty. You actually saw me stick the Fox box into the case earlier with this stuff. It's amazing. I'm going to use it to stick the box to the board. Now, is this dual lock going to work? I don't know. I've never built an off-road board before. I'm sure it'll do something. Might have to change it, don't know. Now remember, I need to leave some of this so that I can do the enclosure too. So I'm going to use dual lock. Right, I only get one go at this, so I need to be very careful. I want to make sure it's straight and it's where I want to position it, and it's also centered. I can pick the board up by the case, so that's probably going to be all right. Guys, the next problem we have, or the next bit to do, is these have got to go into here, and as you can see, the left motor is going to be controlled by the right speed controller, and the right motor is going to be controlled by this left speed controller. It doesn't matter which way round, which controller controls which motor, to be honest, so I've just done it like that so that I could get these controllers closer together. So the general idea is, I think, these are going to be wrapped as I always do. They're going to come down, they're going to be held by the some sort of fixing here, which I've got to make yet, and then they're going to enter in here. So it's essentially going to look like that, but this will all be wrapped. So here it is, guys. This is the stuff that I use to wrap my cables. It's just 15mm nylon braiding, essentially. And all we need to do is just measure the amount we want. And then, guys, it's always important to melt the ends of this, stop it from fraying, because it'll just keep fraying. You just want to melt them together. So just going to push the wires through. I think together is probably best. And then, guys, you might have seen me use this technique before. Should also stop these ends from fraying. And I always reinforce this motor bit. It just makes it look neater as well. Makes it look better. And also has some nice reinforcing properties. Now we need a tie wrap. All we want to do is just keep that heat shrink on there. On there. Top tip for you guys, packet of tie wraps, don't rip the end, rip a hole in the middle. That way they can't fall out, but you can still get them. Right, double zip tied tie wraps, depending on where you're from. We're just going to cut them flush. We need the correct heat shrink for this part. I probably don't want this too wide because I don't want it to stick out too much. Probably half of that. Tell you what I could do with here. I could actually do with taping this nylon braid up. Right, that's it guys. I'll have to make something to hold that there, but essentially that is it. Good. Sensor wires. Now when I get time I'll shorten those, but for now they're okay like that. That should all lay flat nicely. Lovely, so that's the desired effect anyway guys. I'm going to go away and do the other one now, and then I'll check back in for the next part. So there we go then guys, all of the wires are in and where they should be, and yeah, basically it's ready to go. I do have the lid. One thing that has started happening is this, because these walls aren't very thick, the enclosure started bucking out slightly, but it's not too bad. See there, it's annoying. So the next stage guys is the battery. Stay tuned next week for the battery video.